equals the piecewise function x cubed 4x greater than or equal to 1 and a times x minus 2 squared plus b for x less than 1. How would we check for continuity? We know that the limit from the left as x approaches 1 must equal the limit as x approaches 1 from the right, correct? Well, let's do that. So we got x cubed has to equal a times x minus 2. 4x equals 1, right? And we get, what is that? Negative 1 on the inside, negative 1 squared is 1. A plus b. 1 equals a plus b. Oh, we have two variables, one equation. The only way to solve this is have two equations, right? Think we have a system then? Remember those? How are we going to get that? Well, they talked about differentiable, right? Well, now we have to figure out the derivative from the left and the derivative from the right with the a's and the b's in there, okay? So, the derivative from the left, limit, as x goes to 1 from the left, f of x, and then we're using alternative form because we have a c value, right? F of x would be a times x minus 2 squared plus b, okay, minus f of 1. F of 1 would be a times 1 minus 2 squared plus b. And I better put that in brackets so I don't forget some negatives and stuff, okay? All over x minus c.
You just write a plus b.
Hmm?
Did you write a plus?
Where at?
Like on the top.
Right here?
Yeah.
Right here?
Yeah.
What do you mean?
Because that
You could, yeah. I'm just writing out so people can see me substituting in the 1. Okay. Limit x goes to 1 from the left. Man, I don't know if I need to distribute and multiply this all out, so I don't know what I'm going to do here. So I'm just going to go a x minus 2 plus b, and that's going to be 1 times a, so negative a, and that's minus b, isn't it? Over x minus 1. All right, so let's see what we can do here. Limit x goes to 1. Looks like b minus b, right? Now what? We factor out an a, that would be x minus 2 squared minus 1. Looks like we might have to multiply this all out. Let's do it. You know what I like about this, though? What do you guys think I like about this? There's only a's. That's kind of nice. Okay, and what we got here? That'd be ax squared minus 4ax plus 4a minus a all over x minus 1. Okay, limit x goes to 1. Okay, ax squared minus 4ax plus 3a x minus 1. Now I think it would be good to factor out an a, actually. Give me the limit. So it'll be x minus 3, x minus 1. Sweet. Cancel. Substitute 1, and we get negative 2a. But that's all we get. We get negative 2a. We don't have an equation. What does this have to equal, guys? What does the derivative from the left have to equal? The derivative from the right. Well, we better find the derivative from the right now. Good news is, derivative from the right is x cubed. That's not too bad. All right, so limit x goes to 1 from the right. F of x, x cubed, minus f of 1. Yes, we do is plug it in right here. We plug in 1 here. That's just 1, right? All over x minus 1, x minus c. All right, who remembers the difference of cubes factor pattern? It's going to be x minus 1, then what? X squared. Plus what? 1x plus 1. All over x minus 1. Now let this limit go to 1. Let x go to 1, and we get, is that 3 then? So negative 2a has equal 3. Say again? Let x go to 1. Is that what you guys got? Or is that what you're getting now, I should say? All right, so what does a equal then? Okay, so big idea, guys. Continuity, just the limit from the left has equal limit from the right. Differentiability, the derivative from the left has equal derivative from the right. We have 2 equations. It just so happened this one only had 1 variable. I like that. So we can solve for that variable and then plug in over here.
What happens if we have 2 variables?
Then it's a system, pick your weapon. Are you going to use substitution or elimination or something? And about 99% of the time, just use substitution in calculus. Because your coefficients are not always going to line up nicely and everything. Just use substitution. So then b equals, what's 1 plus 3 halves? 5 halves. So a equals negative 3 halves and b equals 5 halves. 2 big concepts: continuity, differentiability.